Welcome to Lesson 3 of the Kubernetes Beginner's Guide. Today we're building the mental model that unlocks every workload pattern you'll ever deploy. It comes down to 3 resources, each with one job. A pod runs your workload, a deployment manages replication and rollouts, and a service gives you stable networking in front of pods that come and go. And the quiet superpower tying them together? Label selectors. The loose coupling that makes Kubernetes feel like magic once it clicks. Here's the roadmap for the next 20 minutes, framed as the SRE loop you already run every day. First, we observe what a pod actually is under the hood: containers sharing a network namespace, a lifecycle, status fields that tell you exactly what's happening. Then we diagnose how deployments work and the key insight that they manage replica sets, not pods directly. Next, we act, using services to route traffic by label instead of by name. And finally, we document, because labels aren't just metadata, they're the composability layer that makes the whole system loosely coupled. So let's lay out the 3 players on one canvas. A pod is your workload unit, one or more containers sharing localhost and IPC, running your app behind an ephemeral IP. A deployment sits above that, managing a replica set to keep N identical pods alive, handling rolling updates, rollbacks, and self-healing. And a service gives that fleet a stable identity, a virtual cluster IP, and a predictable DNS name, so callers don't care that pod IPs come and go. 3 responsibilities, and labels are what quietly wire them together. Let's zoom into that first player. A pod is the atomic unit, one or more containers always co-scheduled on the same node, sharing a network namespace, IPC, and optionally volumes. The minimum spec is tiny, an image, and ideally resource requests and limits so the scheduler can place it sanely. When you need more than one container, reach for a pattern, a sidecar for log shipping or a service mesh proxy, an init container that runs to completion before your main app starts, or an ambassador that brokers outbound connections. And when things go sideways, the lifecycle tells the story: pending, container creating, running, and the dreaded crash loop back off where Kubectl logs. Previous is your first move. Now step up one layer. You almost never create pods directly. You write a deployment, and Kubernetes creates a replica set, which in turn creates the pods. 3 layers, each reconciling independently, and that loose coupling is exactly what makes rollouts safe. With max surge 1 and max unavailable 0, you add capacity before removing any, so traffic never dips. And the operator's reflex is muscle memory: rollout status to watch, history to inspect, undo to roll back in seconds. Now pods come and go, but clients need a stable address. That's the service. Pick the type by where the traffic originates. Cluster IP is internal only, perfect for service-to-service chatter inside the cluster. Node port opens a high port on every node, handy for a dev box, never for production. Load balancer asks your cloud provider for a real external load balancer, and that's what you ship public traffic through. And headless, with cluster IP set to none, skips the virtual IP entirely. DNS returns every pod IP directly, which is exactly what stateful sets and peer discovery patterns need. So how does a service actually find its pods? Not by name, by label. The pod carries tags in its metadata, like app equals web, and the service just declares a selector that matches. Kubernetes does the rest. It builds an endpoints object listing every matching pod IP. Spin up a new pod with the same label and it joins the pool automatically. 0 reconfiguration. That loose coupling is the real superpower, and the same L flag lets you filter anything from the command line. With the mental model in place, here are 6 reflexes worth burning into muscle memory. Always set resource requests and limits. Without them, pods land anywhere, overcommit nodes, and get evicted first under pressure. Pair every apply with Kubectl rollout status to actually watch the deploy land, and remember Kubectl rollout undo is your 5-second panic button back to the previous replica set. Then, Get OYAML piped through YQ for live inspection. Readiness probes so services never route to broken pods, and prototype with kubectl run before wrapping anything in a deployment. Small habits, huge compounding returns. And here's the whole lesson distilled onto one screen. 12 commands grouped by the 3 resources we've been working with. The left column is your pod and deployment lifecycle. Run, scale, undo, describe. The middle is the change and inspection loop. Create, set image, filter by label, pull logs from a crashed container with previous. The right column is everything service-related plus the rollout watcher and port forward for local debugging. Screenshot this one. It's the observe, diagnose, act, document loop in 12 muscle memory commands. Now, the failure modes. 5 mistakes that look perfectly fine in dev and then page you at 3 in the morning. Naked pods with no deployment, so nothing self-heals. Service selectors that don't match pod labels. Always check kubectl get endpoints. Empty means typo. Node port surviving past the lab into production. No resource requests or limits, so the scheduler guesses and the kernel kills. And image tag latest, which silently mutates and erases your ability to roll back. Each one is a label, a field, or a one-line discipline away from being a non-issue. Theory's done, time to put hands on keys. 3 exercises end to end. First, deploy Nginx, scale to 3 replicas, push a new image, watch the replica set swap, then roll it back. That's where the deployment replica set pod hierarchy stops being a diagram and becomes muscle memory. Second, expose it. Delete every pod and watch the service stitch new pod IPs back in automatically, loose coupling in 30 seconds. Third, ship a sidecar, Nginx, plus a busybox, tailing its access log over a shared empty dir. Same pod, shared local host, shared volume. The pattern behind Istio, Datadog, and half of production Kubernetes. And that's lesson 3 in the bag. Pod runs the workload. Deployment handles replication. Service provides stable networking, and labels are the quiet glue holding all 3 together. That's your foundation. Next up, we shift tags from foundations to daily operations and go deep on etcd, Raft consensus, backups, restores, quorum, performance tuning, because when production pages you at 3 in the morning, 9 times out of 10, it's etcd. See you in lesson 4.